Hi everybody. So I am answering the question number 155 or page 155 number 27. And first of all, I'm going to start off with just sort of making a tree diagram. It's not complete, but it's about as complete as I can make it. So the individuals can either have O positive blood or not, and then O positive not, O positive not, O positive not, O positive not, O positive not. Or you can have not, and then the rest of the tree diagram is down here. And the first question asks, what happens if you are trying to find, or what's the probability of you trying to find all 6 people having O positive blood? Well, that would be this path here. O positive, O positive, O positive, O positive, O positive, O positive. And what you do is you multiply the probabilities of each of those O positives together, so you're going to get 0.47 raised to the 6th. The next question asks, what about everybody not being O positive? So that would be this path here, all of the nots. Not. Well, the probability of the nots is 0.53. So you're going to do 0.53 raised to the 6th. Now, there's actually a better way to deal with this, and that is the following way. This is a binomial. There's 2 options, there's a fixed number of trials, and the probability remains the same throughout. So it's a binomial by definition. And so what you're going to do is you're going to hit the second key, the vars key, and you're going to go to binomial PDF. And if you have a newer version of the computer, your trials will be 6. You'll see this thing, sorry. And you'll say trials is 6, P is 0.47, and your X is 6. If you have an older version, you'll see binomial PDF in a parenthesis. So you'll go 6, comma, 0.47, comma, 6, parenthesis. In either case, you're going to get 0.011. And then the second question that we're dealing with would be binomial PDF again. And then you'll have 6.470, okay? Because you're not wanting any of the O positives. Well, you get 0.022. That's this path. The not. And part C needs the tree diagram, at least to get an idea. You see, this path here has 1. And the statement is at least 1. So that path, you go almost to the end, and then you drop down. That has 1. Go down here, that has 2. You go down here, that has 1. You go down here, you got 1 at least. So what happens is this is the only path you don't include, so all of the nots. And the way that works then, to determine the probability, is you know the probability of the 0.53 over and over and over again. So you use the complement. You do 1 minus the 0.022, and that will give you the probability. Now, the last piece, part D. Which ones are unusual? Well, outside of 2 standard deviations away from the mean is an area of 0.05. So, to indicate that you're farther out than 2 standard deviations away from the mean, you do anything smaller than 0.05, and that's considered unusual. So this one's unusual, but when you do this one, it is not unusual. Okay, hopefully that is helpful.